Hello everyone, my name is Harsh Patel and this is the video presentation for the assignment number 3 in Applied Data Science, and this assignment is divided in two parts. So in the first command we are basically just importing the necessary packages and libraries such as NumPy, Matplotlib, etc. And moving forward, what we're doing is we are basically fetching the image from this specific URL and we are storing it in the variable response. And to view the content of that response, you can use this command print response.content, and you can see this is what we get. So basically, in order for us to view the image from that content, we have to open it using this command image.open bytes.io bracket response.content, and storing it in the variable input underscore image underscore AR. We can use the matplotlib library to plot the image, which we are doing in the next command. So this is the image of a car. Moving forward, we are going to apply the techniques of convolution with 2D kernels on this specific car image. Now if I go to question 1, based on the kernels represented on the above image, create a kernel to detect 45-degree lines using convolution, apply to the car's image and then plot the result. So I have to create a kernel which detects 45-degree lines, and then I have to apply that kernel on this image, and then I have to plot the result. So this is my kernel which detects 45-degree lines. I'm using that kernel in this command uh, to apply that over the image, and then I'm plotting the result. So this is what the image looks like after applying the kernel which detects 45-degree lines. In the second question, I have to use the kernel which detects 135-degree lines, and this is my kernel which detects 135 degrees, and I'm using that kernel to apply over the image, and then I'm plotting the result, and this is the result of the image. So the difference is this is slightly darker than the previous image. Moving forward, this is question number 2. Apply the following kernels to your image and plot the result. So basically I have a few kernels and I have to apply those kernels on my image, and then I have to plot the result. So I'm applying this kernel first in over my image, and then this is the result of that kernel. This is kernel number 2. I'm doing the same thing. I'm using kernel 2 for convoluting this image, and this is the result. This is kernel number 3, doing the same thing again, and this is my image number 3. Moving towards part B of the assignment, first of all, I'm importing the necessary packages and libraries. Then in the next command, I'm storing the training and testing data from this data set named CIFAR. So what CIFAR is that it basically is a data set that consists of 60,000 32 by 32 color images in 10 classes with 6,000 images per class. The 50,000 images out of those 60,000 are training, and the remaining 10,000 are testing images. Moving forward in the next command, I'm using one hot encoding method to convert the target values. I'm converting the values of integers to floats. I'm normalizing them, and then in the next command, I'm creating my model. So my model consists of 5 layers: conv 2D, max pooling 2D, flatten, and 2 dense layers. One of them has 128 neurons, and the last dense layer has 10 neurons. And I'm using my activation as softmax, which will give me probability scores, which will all add up to 1. Then I'm compiling my model, and you can also check how many layers we have, what kind of layers we have using this command model.summary, and it's gonna give you statistical view of all the layers that our model consists. Moving forward, we are going to train our network, and we are gonna use 50 epochs. So after our model has finished training, the accuracy that we have reached is 92%, which is pretty good. Moving forward, I'm going to plot the results. And the results that I got from this model number 1 is that based on the graph, as you can see, our model was doing pretty good up until 7th or 8th epoch. That's when our model started showing, that's when our model started overfitting. Now, as mentioned above, our model has 5 layers. These are their names. Now, in this paragraph, I'm explaining what each layer does. What is the purpose of each layer? Convolutional, this layer is known for recognizing local patterns anywhere else in the image that it learns from a particular corner or any specific part of the image. And that is the reason I'm using this layer as the first layer of my model. Max pooling 2D. It downsamples the input along its spatial dimensions, height and width by taking the maximum value over an input window of size defined by pool size for each channel of the input. Flatten. The reason we are using this layer is because we need to flatten the output that we get in 3D after the initial 2 layers. The reason is that our classifier in the model will not be able to process the 3D output, so we need to flatten that output. Dense layer. This is a simple layer of neurons in which each neuron receives input from all the neurons of previous layer. We used this layer to classify image based on output from convolutional layers. We have 2 dense layers in our model, one having 128 neurons as mentioned above, while the other having 10 neurons for the array of probability scores that will add up to 1. Now on to question number 6. Add one or more convolution layers to your model and run it again. So I'm using the same model, but I'm adding one more layer. So basically this model has 6 layers and this is the new layer that I added. Then as usual, I'm going to compile the model and then I'm going to train my network 50 epochs. And this time we got increased accuracy, which is 99%. So in comparison to the previous results, the main difference that we see is in terms of accuracy, which was increased by around 5% in the second model. Now for the question number 8, I'm going to use the same model with 6 layers and I'm going to add a dropout layer to my model right here. And I'm going to use 50% as the value for that. As usual, I'm going to compile my model again and then I'm going to use 50 epochs to train my network. And I got the accuracy of 87% for this model. And I'm going to plot the result in the next command. So basically, what a dropout layer is that it is used to decrease the overfitting of the model. It works by randomly setting the outgoing edges of hidden units at 0 at each update of the training phase. Now for question number 10, I'm going to make a few changes to the hyperparameters. So for my model, I'm changing the number of neurons for this dense layer from 128 to 512, and I'm going to use 60% as the value for the dropout layer. And after compiling the model and then training the network as usual, the accuracy that I got was 97%, which is far better than previous model. And this is the result of that model. So that's everything for my assignment. Thank you for watching the video.